Let's go through input-output devices. Programmer data is read into the main memory from the input device or secondary storage under the control of CPU input instruction. Output devices are used to output the information from the computer. If some results are evaluated by the computer and it is stored in the computer, then with the help of output devices it can represent. The next one is Central Processing Unit. A central processing unit or a CPU is functionally the most important component of a computer system. Without a CPU, any computer is more or less non-functional. It is generally referred to as the brain of computer due to the vast number of functions it performs. The CPU is responsible for carrying out the fetch, decode, execute cycle. The CPU fetches instruction and data from the RAM or CX, decodes then execute. It is separated into the arithmetic logic unit and the control unit.
Let's see Arithmetic Logic Unit ALU. ALU is a digital circuit that performs arithmetic and logical operation on binary numbers. The ALU is a fundamental building block of Central Processing Unit CPU of a computer, and it is typically implemented using electronic gates. Here is the symbolic representation of ALU. The ALU can perform a variety of operations including addition, subtraction, multiplication, and division, and logical operations such as AND, OR, and NOT. Some ALUs also include special purpose operations such as square root and modulo. The input to the ALU is typically two binary numbers called operands and control signal that specifies the operation to be performed. In modern CPUs, ALU is often integrated into the CPU as part of the execution unit. It may also be pipeline, allowing multiple instructions to be executed simultaneously. Overall, ALU is a heart of CPU that performs all the arithmetic and logical operation in the computer.
Hello, I am Nikhil and I will be explaining about the control unit. The control unit is a part of the central processing unit, that is CPU. The CPU is divided into the arithmetic logic unit and the control unit. The control unit generates the appropriate timing and control signals to all the operations involved with a computer. The functions of the control unit are: it coordinates the flow of data out of, into, and between the various subunits of a processor. It understands commands and instructions. It regulates the flow of data within the processor. It accepts external commands or instructions which it turns into a series of control signals. It is in charge of a CPU's multiple execution units such as ALUs, data buffers, and registers. It also performs a variety of activities including fetching, decoding, handling execution, and storing results. Thank you.
Hello friends, this is Ayush Patle and I am going to explain you the memory unit of the von Neumann architecture. So the memory unit is a component of the computer system that stores data and instructions. It is responsible for holding information that can be accessed by the processor, allowing it to perform calculations and other operations. The memory unit is typically composed of RAM, which is random access memory, and ROM, which is read-only memory. RAM stores data temporarily while ROM stores the data permanently. The process of saving the data right after its execution is denoted as fetch, decode, execute cycle, and in this cycle, the memory address held in the program counter is copied into the MAR, which is memory address register. Next, in the next slide, we will see about the processor speed. So the processor speed is measured by the number of instructions a computer can execute in a second, and the unit of processor speed is hertz. A single instruction of the fetch, decode, execute cycle is called as the clock cycle, which determines the processor speed. For example, the AMD Ryzen 7 series operates on 2.9 GHz of processor speed. Nowadays, the speed of the processor has become a deciding factor while buying a laptop, as these processor speeds tell us the overall story about the speed and the accuracy of the processing a particular instruction and improves the overall user experience.
Hey everyone, this is Aditya and my roll number is 34. I shall be explaining you about the types of bus. The bus is the collection of the lines. The bus is a set of the parallel wires connecting two or more components of a computer. Typically, it consists of 8 1632 or the 64 lines. They connect all the components, input output devices to the CPU and the RAM. Also, they allow the transfer of data between the components. There are three types of buses. The first is address bus, second is the control bus, and third is the data bus.
Hello everyone, my name is Patrice Adlino and I'm here to explain to you address bus, control bus, and data bus. So I'll start with the address bus. The address bus is used to identify locations in the components by transferring memory addresses to either the memory or the input output component in a unidirectional flow. The address may be for a location of an instruction or piece of data to be fetched or stored. So the address bus is used to transfer data between devices that are identified by hardware address of the physical memory, which is stored in the form of binary numbers to enable the data bus to access memory storage. The control bus. The control bus is used to send signals that coordinate the flow of data and manage the activities of the peripheral devices. It transmits command, timing, and specific status information between components. And this can only occur through physical connections such as cables or printed circuits. The data bus, the data bus transfers data and instructions between peripheral devices, memory, and the CPU.
Hey guys, this is Aditya again. So, this was all about the von Neumann architecture, which is based on the idea that all the data and the address bus must be shared by all components in a computer. Each bus is shared transmission medium, so only one device can transmit along the bus at any given time. The control bus is bidirectional, so signals can be transferred in the both directions. So this was all about the von Neumann architecture. If you like the video, do share, do comment below and let us know your feedback for our video. Thank you.